So thank you for being here. I want to thank KC for organizing this. My name is Roger Royce. I'm the founder of the Royce Law Firm. We're a business, corporate, and tax law firm that services technology startups. And of course, health tech is one of our big initiatives. This is the first of a series of events that we're going to be hosting for Pitch Global throughout the year on health tech. Now, I know that not everybody is here yet, but I'd like to get a sense as to who's in the audience. How many tech startup entrepreneurs? My God, almost everybody. Any product people, from bigger companies, from industry? Okay, a few. Well, okay, or smaller companies. Product people, all right. Investors, VCs? A few of them, okay. I know more are on the way for our later panels. Well, we are really excited and pleased today to be able to welcome Professor Thomas Sudoff to speak with us, to do a little bit of a fireside chat. And we don't have a lot of time. I've got a few things I want to get across, and I'm going to open it up to a few questions from the audience. But for those of you who don't know, Thomas is a biochemist. He's known most for his study of synaptic transmission. He's a professor in the School of Medicine in the Department of Molecular and Cellular Physiology, and also in neurology and psychiatry and behavioral sciences at Stanford University. And of course, he is the 2013 Nobel Prize in Physiology or Medicine Laureate. Thank you. Prior to that, Thomas worked on a project to describe the role of, you'll understand this more than I do because you're all health tech people, the role of the LDL receptor in cholesterol metabolism, the statin drugs. So that was based on some fundamental research that Thomas worked on for two gentlemen who were awarded the Nobel Prize in Physiology or Medicine in 1985. So he's been at it a long time. Thomas has been at Stanford University since 2008, where, as I said, he's a professor in various departments. And he's credited with discovering so many things. I mean, I printed it out, but I can't read all of the things, all of his accomplishments. But like I say, probably what he's most well known for is brain science, synapse formation. So with that, Dr. Sudoff, I think I would like to just ask you maybe to describe a little bit in layman's terms for me, what it is that you did to be awarded the Nobel Prize.
I am originally a biochemist, but as science has developed over the last decades, we all have become interdisciplinary. So I wouldn't describe myself as a biochemist or physiologist or whatever you want. It sort of fits. And that is also reflected by the fact that I am a member of so many different departments. I'm even a professor of neurosurgery, although I have blissfully never seen a patient in a OR, at least in a neurosurgeon OR. Anyway, my work originally focused on how one nerve cell sends a signal to another nerve cell during synaptic transmission. And that was the work that was honored by the Nobel Prize. And that work tried to understand how it is possible for a nerve cell to send a fast signal very precisely in a very, very short time. That was a mystery in many ways before we started, because everyone knew that synapses transmit information within a few milliseconds. And everyone knew that that occurred because the chemical transmitter was being used as the signal. Since then, our work has shifted. We now work on trying to understand better how the brain is wired, how it is possible for many, many synapses to form in the correct space and time, and how they change during synaptic plasticity. And We also work intensely on trying to understand what happens in diseases that affect those processes. Diseases such as neuropsychiatric disorders and neurodegenerative disorders. And that, in a nutshell, is my academic work that I'm performing in my lab at Stanford. In addition to directing a lab, I'm very interested in drug development at a number of levels. And I'm working with a number of companies, mostly in an advisory role. One of the most depressing things about drug development, at least as far as the brain is concerned, over the last decades has been the lack of success in trying to combat neurodegenerative diseases, Alzheimer's, Parkinson's, ALS, Huntington's. And I think that this is now beginning to change. But it took, for those diseases for which there finally is progress, let's say Huntington's, it really took a huge investment in fundamental research in order to achieve that. Only recently has there been appreciation that it is not just A beta that creates the disease, although I feel that we need to have a very, very general perspective that includes not only neurons, but also not only microglia, but that really includes an interaction between different types of cells in the brain and their dysfunction in order to understand, because despite the recent progress, especially in genetics, we still don't understand the disease, or for that matter, I don't think we understand any neurodegenerative disease.
To ask you to tell us a little bit about the future, especially the future of drugs. What sorts of drugs that you think companies will be developing? Will it be biologics, small molecule? For the future, where are the opportunities here for our group of entrepreneurs? What's your opinion?
I feel almost like we are now beyond the apex, beyond the climax of the biologics as an approach, certainly in disorders of the brain, but possibly even in cancer. And to me, it seems clear that the most exciting opportunities lie in manipulations that affect gene expression, RNA therapeutics, DNA therapeutics, gene therapy of one kind or another. I think that the approaches that companies like Ionis or Animam have pioneered are incredibly promising, although the clinical trials still need to be done.
And I've been reading some of the things you've been posting, the Washington Post article, for example, and some of your other articles. And I wonder, does this signal a shift in your writing? Can we expect from you more accessible explanations of the science and the brain and what you do? Or do you think you'll spend your career more focusing on the research that you're doing at Stanford?
I would hope to do both, because it is actually very hard for scientists like me to explain what we are trying to say in a way that other people understand us, especially the public. And I think that academic scientists have made a major mistake in the United States for sure, but also worldwide, in not paying more attention to communicating to the public. Talking about societal burdens, however, disorders of the brain are at least as burdensome, both economically and in terms of personal suffering, as are disorders like cancer. With cancer, finally there is progress, I think. I have the impression, and although the majority of cancers still cannot be treated adequately, at least a minority can now be treated in a way that gives rise to hope. And that after all this investment. So I think we need to really communicate to the public that although there are opportunities of translating neuroscience research, those opportunities are still small because the progress in trying to understand the diseases of the brain has been very little.